Hello, welcome to Engineers Mindset. So we are still on differentiation of inverse trigonometric functions. Let's say we have y to be equal to sine inverse of 3x squared plus 5, and we are asked to find the y all over the x. Okay, so as usual, y equals sine inverse of 3x squared plus 5. Simply say let a be equal to 3x squared plus 5. Simply the variable in front of what the 3 function. Let's call that a. If that happens, this actually now implies that y itself is actually what? Sine inverse of a, because we said let a be the whole of this term. So if we take this term off, we're replacing it with a, it means y becomes sine inverse of a. So from analysis, I've already said if this happens, it now means that y is a function of a. So this actually implies that y is a function of a, and a is a function of x. So which means we have function of a function, and I've always said if you have function of a function, the only rule we can use to differentiate is actually what? The chain rule. Okay. So if y is a function of a, I said this actually means that we can only differentiate y with respect to a, because y is a function of a. And from here, a depends on the variables of x to be defined. So which means a is also a function of x now. And if this happens, it means I can only differentiate a with respect to x. And if I'm able to establish these two facts, it means now that the y dx lies in multiplying these two derivatives together. Therefore, the y dx can only be obtained by multiplying these two variables, the y dA by the a all over the x. And this is called the chain rule of what? Differentiation. So from here, the a can cancel the a, and we're left with the y, the x. So which means all I need to do now is simply what? Find the y, the a, and also find the a, the x. Let's do that now and see. From y equals sine inverse of a, which is simply here, from y equals sine inverse of a. Like I said, I can only differentiate y with respect to a. So that gives me the y dA. And the y dA is simply what? 1 all over the square root of 1 minus a all squared. So once again, please look up the previous videos on how to differentiate inverse sine function to properly understand how this happens. But if you differentiate y with respect to a, when y is sine inverse of a, you're going to obtain this as the result. But not forgetting, not forgetting that a itself is actually what? We said let a be 3x squared plus 5. So a is actually 3x squared plus 5. This means that the y all over the a is now equal to 1 all over the square root of 1 minus, in place of a squared, we simply have 3x squared plus 5 all squared. Okay, so you simply have this. So you may choose to leave the answer, this particular derivative, like this. Okay, or if you want to expand the bracket, you can as well go ahead to expand the bracket, and whatever value you have, add it to 1 or subtract it to 1 to give you a single variable. Okay, all right, so we have the y dA to be that. Next up is to find the a dx from the formula. Find the a dx. So from a we said let a be simply 3x squared plus 5. All right, from a equals 3x squared plus 5, we can now differentiate a with respect to x. That's the a dx, and that's simply, if I differentiate 3x squared here, if I differentiate x squared, I will simply use that 2 to multiply what? The whole of this value. It becomes 6. So 3x squared, so if I differentiate 3x squared, I will simply have 6x. Okay, and if I differentiate 5 is a constant, The derivative of a constant is what? 0. So that's nullified. So I have the a dx. So if I have the a dx, I have the y dA. I can now employ the chain rule to find the y dx by simply what? Multiplying these two derivatives together. Okay. Alright, so this simply now implies that the y all over the x is now equal to, so we simply said the y dA, and the y dA gave us this 1 all over the square root of 1 minus 3x squared plus 5 all squared multiplies by the a dx simply gave us 6x multiplies 6x. So this simply implies that the y all over the x is actually 6x all over the square root of 1 minus 3x squared plus 5 all squared. That becomes the answer to that derivative. Once again, if you choose to want to expand this, you can go ahead and expand that. But that remains the answer. Alright guys, I hope you find this video very interesting and helpful. Please, if you do, I would like to get your thoughts in the comment section. And if you're new to the channel, please don't forget to hit the subscribe button to keep getting updates on content such as this and more. I will see you in the next video with wonderful questions on differentiation of inverse trig functions. Thanks guys and cheers.